This video is about the differentiation of logarithmic and exponential functions. First, let me recall the properties of logarithms in general. Previously, what I gave you were the properties of natural logarithmic expressions. So this time, I'm going to give you the properties of logarithms of any base b. So the first one is the logarithm of x to the base b plus the logarithm of y to the base b is equal to the logarithm of x times y to the base b. So if you want to simplify logarithm of x plus logarithm of y to the base b, you simply have to write it as logarithm of x times y to the base b. The second is the logarithm of x to the base b minus the logarithm of y to the base b is equal to the logarithm of x over y to the same base b. The third one is the logarithm of x to the n to the base b is equal to n times the logarithm of x to the base b. May just remind you that all these properties go for all logarithm of any base. Okay. The fourth one is the logarithm of b to the x to the same base b is equal to x when we simplify. And the last one is b raised to the logarithm of x to the base b is equal to x when simplified also. As you may know by now, logarithm of any number, real number x to the base e is simply written as the natural logarithm of x. Okay, so logarithm to the base e is the same as ln. Okay, so therefore all these properties given are also applicable for the natural logarithmic expressions. So previously I have written these properties for specifically for natural logarithmic expressions. This first one is equivalent to ln of a plus ln of b equals ln of a times b. May just remind you of these properties. The second one is the same as ln of a minus ln of b. Well, I'm just using a and b here, and on the other side I used x and y, but it's the same exact same properties. The third one is for ln of a to the r is ln of r ln of a. And the fourth one is ln of e raised to x when simplified is x. And the fifth one is x, or sorry, that's the fifth one is e raised to ln of x equals x also when simplified. So take note that ln is just logarithm to the base x, to the base e, sorry. Right? So we'll be using these properties to simplify logarithmic functions. So here are the formulas for differentiating logarithmic and exponential functions. From this moment on, all the formulas that I'll be giving you will be in terms of u instead of x. All these formulas are generalized based on the chain rule. Differentiation formula number 7 is for the derivative of logarithm of u to any base b. Okay. So u may be a function of any variable here. So this is equal to 1 over u logarithm of e to the same base b. Okay, so d7 is for logarithm of any base b, including ln. But differentiation formula number 8 is specific for logarithm to the base e, so that's for ln of u. And this is equal to 1 over u times du. Oh, I forgot to include du here. Okay, du is the derivative of this expression. Don't forget. Also here, du is the derivative of this expression. So d7 and 8 are for the derivatives of logarithmic functions. d9 is for the derivative of an exponential function, a to the u. Okay, where a is any constant and u is a function of any independent variable. So this is equal to a to the u ln of a times du, where u is the exponent of a and du is the derivative of the exponent of a. So d9 is for any exponential function, so any base a, while the 10th formula is for a specific function, the natural exponential function e to the u. So that is just for base e. For base e and any exponent u, as long as u is a function of any independent variable. So this is just e to the u. Based on d9 also, you'll have, in d9 it's a to the u ln of a, but a here in d10 is e, and ln of a here would be ln of e in d10, so but ln of e is just 1, so it's just ln of e to the u du. Okay, so these are the formulas that you need to memorize for differentiation of logarithmic and exponential functions. Now let's have some examples. So when I say find the derivative of each of the following functions, then I mean just the first derivative of the function. So number 1, the function is y equals ln of the square root of 1 plus 2x. Okay, so you have to write the function in number 1 in the form of ln of u. So let u, in this case, u is equal to this expression. That is u. So if we differentiate y, we differentiate it with respect to x and we'll get y prime. That's according to the formula, the derivative, according to d8, the derivative of ln of u is 1 over u du. So it would be 1 over u, where u is square root of 1 plus 2x times du. The derivative of u, where u is square root of 1 plus 2x. Okay, so we just have to get the derivative of 1 plus 2x using the general power rule. So let's find the derivative of the square root of 1 plus 2x. Okay, well, of course, whenever we see a radical in the function, we write it using a rational exponent. So we're taking the derivative of 1 plus 2x raised to 1/2. Recall the general power rule. The derivative of u to the n is equal to n u to the n minus 1 times du. Okay, where du is the derivative of the base. So the derivative of square root of 1 plus 2x is the same as the derivative of 1 plus 2x raised to 1/2. So using the general power rule that I have written, it's the exponent is 1/2, so you bring down the exponent, copy the base 1 plus 2x. When we subtract 1 from the exponent, we'll get a negative 1/2. And then du is the derivative of the base, where the base is 1 plus 2x. The derivative of 1 plus 2x with respect to x is, of course, 2. Okay, simplifying, we'll get 2 over 2 equals 1. And we don't want the negative exponent in our answer, so simplifying it, we get 1 over 1 plus 2x raised to 1/2. This is the derivative of square root of 1 plus 2x. Alright? Or simply in radical form, that is 1 over square root of 1 plus 2x. So now going back to y prime is equal to 1 over the square root of 1 plus 2x times derivative of square root of 1 plus 2x, which is equal to 1 over the square root of 1 plus 2x. So square root of 1 plus 2x times itself in the denominator, we get y prime equals 1 over 1 plus 2x. This is the derivative of the function. Example number 2, we have y equals logarithm of 4x minus 1 over 4x plus 1 if you don't see the base of the logarithm. So it's a common logarithm to the base 10. And we don't have to write 10 anymore if it's the base. So this portion is equal to u. And in the formula, that's formula number 7, so D7, to get y prime, we have the form, the derivative of logarithm of u to any base b, where u here is the quotient of 4x minus 1 and 4x plus 1. So is equal to 1 over u. So that's 1 over u, where u is 4x minus 1. Look at the formula number D7, 4x plus 1, times logarithm of e to the base b. Okay, but the base here is 10, so we don't have to write it anymore, times du, where du is the derivative of u, and u here is 4x minus 1 over 4x plus 1. So how do we differentiate 4x minus 1 over 4x plus 1? We use the quotient rule. So in the quotient rule, let u be equal to the let the numerator be equal to u, and let the denominator be equal to v. Okay? So the formula goes like this. So it's v times du. So let me just recall that so that you'll remember. Derivative of u over v is v du minus u dv all over v squared. Okay, so it's now v times du. What is du equal to? That's the derivative of u in the numerator, 4. Minus u. U is 4x minus 1. And dv is the derivative of the denominator, which is also 4. Over 4x minus plus 1 quantity squared. Okay? Continuing, so the derivative of 4x minus 1 over 4x plus 1 is equal to, we remove the grouping symbols in the numerator, and we'll get 16x plus 4 minus 16x plus 4 all over 4x plus 1 quantity squared. Alright, so 16x minus 16x is 0. So in simplified form, the answer is just 8 over 4x plus 1 quantity squared. This is the derivative of 4x minus 1 over 4x plus 1. Now we go back to y prime. Y prime is 1 over 4x minus 1, 4x plus 1. This part, when simplified, let me encircle that using red ink. So when simplified, you'll have 4x plus 1 over 4x minus 1. Okay, so this is the encircled part. That's it. And then you have logarithm of e to the base 10. And then times derivative of 4x minus 1 over 4x plus 1, which is equal to 8. We obtained 8 over 4x plus 1 quantity squared. We just have to simplify. You have here 4x plus 1. Looking at this, divided by this. So we'll have to cancel this out, and then this exponent becomes 1 as we do that. So simplifying our answer, rewriting and simplifying, you'll have 8 logarithm of e in the numerator over the denominator. We have 4x minus 1, 4x plus 1. Okay? Now, by special products formula, we can simplify the denominator, and you'll get 8 logarithm of e over 4x minus 1 times 4x plus 1 will give us 16x squared minus 1. Okay, 16x minus x squared minus 1 is shorter than what's above it. So this is the derivative of the function in simplified form. Now this is example number 3. Y is equal to 1 over ln of x plus ln of 1 over x. Okay, we rewrite the function first so that we can differentiate it easier without using any quotient rule. So y, we're not differentiating yet, I'm just rewriting, can be written as ln of x raised to negative 1. Okay? When we write ln of x in the numerator, it becomes ln of x raised to negative 1 plus ln of x raised to negative 1. So these two are different things. In the first term, ln of x is raised to negative 1. In the second term, only x is raised to negative 1. To differentiate the first term, we need the power rule, general power rule, okay, where u is the base ln of x. This is u. And then for the second term, we need to use the formula for the derivative of ln of u, where u is, this is u here. U is x raised to negative 1. Okay, for y prime, using the general power rule for the first term, we bring down the exponent, we copy the base, and we subtract 1 from the exponent. When we subtract 1 from negative 1, we get a negative 2. Okay, times the derivative of the base. That is the derivative of ln of x. Don't forget that. Plus the derivative of ln of x raised to negative 1. In the formula, in finding the derivative of ln of u, it's 1 over u. So it's 1 over u, this is u, times du. So derivative of x raised to negative 1. Of course, using power rule. So simplifying, this is negative 1 over ln of x squared times the derivative of ln of x, which is just 1 over x, times the derivative of x, which is 1. Plus, to make this exponent positive, we have to write x in the numerator. So x times the derivative of x raised to negative 1. Using power rule, it's negative 1 x raised to negative 2. Okay? So it's negative 1 over x. We can write ln of x squared as ln there, squared x, or that's squaring the whole expression ln of x, minus x over x squared. Alright, so x over x squared when simplified is 1 over x. Ln of x squared minus 1 over x. We can opt to factor out the common expression between the two terms. We have a common expression, negative 1 over x. If we do that, we'll be left with 1 over ln of x squared in the first term and then plus 1 in the second term. Okay, this is the derivative of the function. I hope you have seen how the difference between differentiating 1 over ln of x and ln of 1 over x. In the function in number 4, we can apply formula D9. This is in the form a to the u, where this is u, and a is equal to 3. Okay, so we just recall the formula. D9, derivative of a to the u is equal to a to the u ln of a times du. Okay, where du again is the derivative of the exponent of a. So f prime of x, using that formula, is 3 to the u, okay, ln of a times du, where u is equal to 4x ln of 3 times du, where u is 4x. What is the derivative of 4x with respect to x? It's just equal to 4. So 3 raised to 4x ln of 3 times 4. Okay. Okay, we don't multiply 3 and 4 because 3 is ln of 3 is the expression, and we cannot multiply that by 4. So what we'll have here is 3 to the 4x times 4 ln of 3. That's the correct way of writing it. Or we can write it as applying a property of logarithm. 3 to the 4x, that's ln of 3 to the 4th. If it's not a very large number, you can do that. 3 to the 4th is 81, so it's 3 raised to 4x ln of 81. So if it's not a very large number, you can do that. But if it's a large number, you don't have to do that anymore to simplify your answer. This is the derivative of the function.